Hey friends, today begins lesson one of a brand new unit. Okay, so we're starting unit four, which is going to talk about angles and triangles. Okay, this also begins kind of the back half of 20-2. So far, if you are following me in school, we have done quadratics, which was quadratic functions and quadratic equations. And then we did radicals, and then we did logic. And for my kids at school, that also means you wrote your first cumulative exam. And now we're going into the back half. Most kids find the back half easier than the front half. So if you've been struggling with a lot of the stuff that we've been doing thus far, I'm hoping I can say positively that things are going to get better for you for this back half. Okay. But where you'll see your mark boost is if you keep that work ethic that you needed in the front half, if you keep that in the back half. So, keep getting all your homework questions done. Keep doing extra practice when you can and when you have time. Keep doing question asking. That was really bad grammar, but keep asking me lots and lots of questions, okay? And that'll really help solidify this back half, okay? Now, today I'm going to take you down a trip down memory lane. In this unit, we're going to begin looking at this picture again. Now, this comes from junior high. Do you remember having to look at two parallel lines and a transversal in between? Okay. Now, for some of you, you're already screaming because you do remember it. For some of you, you're like, we never did that. It doesn't matter. Okay. We're going to get everybody on the same page. And today, we're actually only going to talk about one specific item from this sort of setup. As we progress, we'll talk about some other connections between angles as well. But let's say that these guys are parallel. So I've got these little arrowheads. Just tell me that these two lines are running parallel. I really need to tell you that because my drawing, they don't look parallel. Okay, so what we're looking at is this angle here and this angle here. That's what we're going to study today. Okay, what I want you to notice is that in this intersection, let's just for simplicity's sake right now, say that that's the bottom left-hand corner of that intersection, right? Over here, it's also the bottom left-hand corner. And so what we say is they're in the same spot on the two different lines. They're both in the bottom left-hand corner, okay? And those are called corresponding angles. And that's what we want to kind of play around with today is just this concept of corresponding angles, okay? So let's go through. There is going to be some vocabulary that you have to figure out here. So make sure you're taking your time to learn the vocabulary because when you're doing a quiz or a test, you want to be able to speak the right vocabulary. A lot of this is a communication piece, okay? I'm just going to hide my head for a sec. A transversal, that's this red line right here. The transversal is the line that intersects. Intersects just means goes through, okay? Two or more lines. So it's a line that goes through two or more lines. Now, when we take a look at angles A, B, C, and D down below, they are called interior angles, and they're formed by a transversal with two parallel lines, and they lie inside the parallel lines. So we call them interior because they are inside those two parallel lines, okay? As opposed to the next set that I'm going to show you, which I'll hide my head one more time, angles E, F, G, and H are called exterior angles, and that's because they're on the outside of the parallel lines, okay? They're on the outside of the parallel lines. Okay, one exterior angle and one interior angle that are non-adjacent to each other and on the same side of the transversal. Now, that's a big, complicated mathematical way of saying, hey, look, both of these angles, just let me get my ink going again here. Sorry, I lost where my mouse was. Oh, my ink is on. Okay, both of these angles are in the bottom right of the intersection, okay? That's what we're saying when we say non-adjacent to each other and on the same side of the transversal, okay? So those are called corresponding angles, and we look for an F, okay? So we'd be looking at something like this. for the F, okay? Everybody see that F there? Okay, define and draw a diagram that illustrates vertically opposite angles. Vertically opposite angles just have an X. They're just two intersecting lines, okay? There's no parallel, there's no transversal, just two intersecting lines. And then what happens is the corners that are opposite of each other always equal each other. So here I've labeled these guys as theta. That's one way to represent an angle. And then this side also would be equal to each other. So I've labeled those guys as alpha. Again, I'm just going to hide my head so you can see the word vertically opposite angles there. Okay. And then I'll just write that explanation over here. Vertically opposite angles are those angles that are opposite to two intersecting lines. They will always equal each other, okay? So we've got the thetas represented here, and then I don't think I said alpha. This is the Greek letter alpha, just another way of representing an angle. We've got alphas represented there. Okay, so use geometry to determine the measure of the missing angles. Now, in your book, it actually says use a protractor as well. I'm going to tell you right off the bat, just for simplicity's sake, with the video, that corresponding angles, if they're parallel lines, corresponding angles equal each other. So I know right away that this guy and this guy are going to be corresponding. So I know they're going to equal each other. But I actually have enough information to get A, B, C, D, E, and F, and G. Okay, so let's start with A. I know that this is a straight line. And I know that all angles that form a straight line together have to equal 180. That's called supplementary. Supplementary means they add up to 180. So I can go 180 minus 40 to get my A value, okay? So 180 minus 40, sorry, minus 140 would give me 40. Okay, 180 minus 140, I shouldn't have said 180 minus 40 there, sorry. 180 minus 140 gives me that 40. B, well, B is vertically opposite to 140, so it's also 140. C, I could look at two things now. I could say C is vertically opposite to A, or I could look at, just let me get ink on again here. I could look at 140 plus C would have to add up to 180. So I could go 180 minus 140 to give me C. No matter how I go look at that, I'm going to get C is 40 as well. Okay. F is going to be 140 because it's corresponding. Okay. Then I can do all the same process for E, D, and G that I did for A, B, and C, right? E is vertically opposite to F, so it's also 140. D is 40 because F plus D would have to equal 180. They're supplementary. Or the other way I did it on the note is I said, hey, D is corresponding to A as well. Okay. And then G is 40, vertically opposite to D. I could have said E plus G is 180. I could have said F plus G is 180. I could have said G and C are corresponding. All of those statements would have been proof as to why G was 40 degrees, okay? So again, just for clarification, I could have said G and D are vertically opposite. I could have said E and G are 180. F and G are 180 because they form those straight lines. Or I could have said G corresponds to C, and I already knew what C was, okay? All right, and I will just hide my head for 1 second there just to make sure you all have the answers written in. All right, awesome. Make a conjecture then. Okay, so my conjecture on the measure of corresponding angles and parallel lines. So this is what I'm going to say, and this is what you need to have in your notes. Given a transversal that intersects two parallel lines, corresponding angles will equal each other. Okay, corresponding angles will equal each other. So angles in the same position, if the lines are parallel, will equal each other. Now, we can go both ways with that. We can see that corresponding angles are equal and therefore conclude that the lines are parallel, or we can see that the lines are parallel and then therefore conclude that corresponding angles have to be equal. We can use them in both different ways, okay? Okay, so is AB parallel to CD? Well, I'm gonna try and look for corresponding angles. These are corresponding angles, okay? For lack of a better thought, they're in the top right-hand corner, right? So corresponding angles do not equal each other. And because corresponding angles do not equal each other, these are not parallel, okay? So AB is not parallel to CD because corresponding angles G and H are not equal to each other. Now, I related them to G and H just because they were labeled here, okay? But you can imagine that 180 minus this and 180 minus this still are not going to be the same number, right? Okay. Oh, I didn't mean to go there yet. Just clear that ink. Okay, so let's try this. Again, we're going to relate it to G and H. So if I know that 113 is sitting beside G, I can go and say, okay, well, G will be 180 minus 113, right? And then H, well, I know that this forms a straight line. So H and 113 have to add up to 180. So I know that H is also 180 minus 113. That tells me G and H are equal to each other, which means these lines are parallel because corresponding angles are equal to each other. So AB is parallel to CD because angles G and H are congruent. They're equal to each other. Okay. All right, let's try this one. If I know that opposite G is 86, that tells me G has to also be 86, right? Because those are opposite of each other. And I know that H has to be 180 minus 80, or sorry, minus 94, because H and 94 form this straight line here. Okay, so 180 minus 94 is 86. So again, these guys are parallel. A, B, and C, D will be parallel because the corresponding angles are equal to each other. So AB is parallel to CD because corresponding angles G and H are congruent. Okay, so these are the sorts of conversations you're going to have with yourself throughout today's lesson. Okay, and then we're looking at this guy. So I know that G would have to be 138 because it's opposite the 138 that's there. And then I know that H would have to be 180 minus 41 because that's going to form a straight line. Those guys would be supplementary. Okay, 180 minus 41 is 139. So I have 138 and 139. These are not parallel lines because the corresponding angles do not equal each other. Okay, AB is not parallel to CD because corresponding angles G and H are not congruent to each other. Okay, we got this. All right, I'll just hide my head for 1 sec so you can see the directions. In each diagram, determine whether AB is parallel to CD. So same sort of conversation. I'm just going to change my explanation slightly now and not just talk about that one angle that was stated because those aren't corresponding anymore, right? X and Y aren't corresponding. Now what I'm going to do is I'm going to use that as point X. So if I use that as point X, what I can do is now I can call this angle AXW or BXW. So AXW would have been this guy here, and BXW would have been this guy here. Okay, so I can use the letters to determine the various angles that I need. Okay, all right, so I do know that AXW is going to be 105. That's probably the quickest way to do this. Those are vertically opposite. Okay, so AXW is 105, and then that tells me corresponding angles are equal, so I can conclude AB is running parallel to CD. Okay, because I've got this and this in the corresponding angle section. Okay, let's try B. Now, those are not corresponding angles, right? But I do have enough information now to figure out what AXW is again. This would be 180 minus 95, and that would be 85, right? So AXW is 85, and that would be in the same position as CYX, okay? So then I can see that corresponding angles are not equal to each other, okay? So AB can't be parallel to CD because those corresponding angles don't equal each other. Now, I chose to focus up here and make these two corresponding. You could have easily chose to focus down here and make those two corresponding. Doesn't matter, okay? All right. Let's try this one then. Okay, and so I can go right here and say, okay, those are vertically opposite to each other, so that has to be 63 degrees. And then I can see that this and this are corresponding. And so corresponding angles equal each other. These guys have to be parallel to each other, okay? Now, I can't actually remember if that's the way I did it on the slide or if that's just the way I did it right now. AXY is 63. So I went AXY. Oh yeah, so I just went the other way. I said that this guy in here, if you can see my mouse, was 63 and did corresponding angles that way. There's many ways to answer these questions, right? So angle AXY is 63 degrees. So corresponding angles are equal, and therefore I know AB is running parallel to CD. Okay, and then we've got D here. So I could again just right away go AXW. I know that's 73. Now that would correspond to right here. So I'd have to go 180 minus 107 as well. That's also 73. So because of that, I'm able to say that corresponding angles are equal, and that therefore AB and CD are running parallel to each other. So what I did in my explanation is I went to angle AXY. So AXY is this guy right here, and I know that that guy right there was 180 minus 73 because it has to form this straight line right here. Okay, 180 minus 73. That gave me 107, and then I can see that this guy and this guy are corresponding, and they both equal 107. So that's what's allowing me to conclude that they are running parallel, AB and CD. Okay, so that's all you're doing today. In summary then, when a transversal intersects a pair of parallel lines, the corresponding angles that are formed by each parallel line and the transversal are equal. So we see A and E, B and F. These are just all the pairs of corresponding angles that we can have. C and G and D and H. When a transversal intersects a pair of lines, creating equal corresponding angles, the pair of lines has to be parallel. So we can go in both directions, okay? Okay, so when a transversal intersects a pair of non-parallel lines, the corresponding angles are not equal, okay? There are other relationships among the measures of 8 angles formed when a transversal intersects 2 parallel lines. Things like alternate interior angles, and we'll have to talk about that. And we'll have to talk about alternate exterior angles, but we'll deal with those guys in a couple lessons. Okay, so for now, you're just going to focus on vertically opposite and corresponding. Those are your 2 for today. I've given you your pages for homework that I want you to practice through. Make sure you're trying to write an explanation on everything too. You can't just say, yes, they are, or no, they're not. You have to give me a reason. You have to back yourself up. And make sure you're asking me lots of questions, okay? You know where to find me. You got this, guys. Take care.